Associate Professor
This call is now being
in
recorded.
Vignan Foundation for Science Tech and Research since 2019. He has 17 years of teaching experience as Associate Professor and Lecturer in various colleges. He completed his PhD in Information and Communication Engineering from Anna University, Chennai. During his PhD journey, he done a thesis named A Certain Investigation on Conventional and Optimized Wavelets for Automated Glaucoma Diagnosis. He has done his MTech in the field of biomedical signal processing and instrumentation from Sastra University, Tanjavur. He has completed his BE in Electronics and Communication from Saranathan College of Engineering, Trichy, and also completed 2 intermediate level courses in Coursera. In addition to this, he has published various papers in IEEE, Springer, SEIE, Indexed SEI, and other reputed journals. He also attended many workshops and symposiums such as MATLAB and its applications, advanced medical imaging, and so on. Furthermore, he has also handled administrative roles like institution level research, council coordinator, department level IIPC coordinator, and also participated in BOS meeting for medical electronics in UTV Bangalore. It's a proud privilege to have you here, sir. Now I like to invite Dr. Raja Chandrasekaran to take over the session.
Yeah, thank you. I hope I'm audible.
Yes,
Dr.
yes.
Hemakumar, shall I start the session?
Yeah, you can start.
Okay, today's session is AI in medicine. And I welcome you all. I'm Dr. Raja Chandrasekaran, Associate Professor from Vignan's Lara Institute of Technology and Science. And today, on AI in medicine. Welcome you all to the Physiological Control and Internet of Medical Things conducted by Pondicherry Technological University. And I extend my thanks to the Chief Patron, Principal, and also the Patron Dean of COE, and Professors Dr. Ramesh Babu and Trisakti Murugan, and Coordinator Dr. Hemakumar, also the co-coordinators and the organizing committee members. I extend my thanks for providing the particular opportunity. And as I told you, the today's session on AI in medicine with implementation perspectives. So I would like to divide today's session into 3 sessions. That is, initially we are going to see the introduction about the deep perspective of machine learning versus deep learning. So we are going to understand what is the difference between machine learning and with respect to that the basics of machine learning, like artificial basics. And when it is coming to artificial neural networks, we need to understand what is meant by backpropagation neural networks and feature extraction and classification. And essentially, we need to know about supervised and unsupervised learning. So I know that there are a wide range of audience here, starting from students to esteemed professors. So if I am sticking on to some of the basics, kindly excuse me. I just intend to provide a content that will be suitable for everyone, that everyone can listen and have some outcomes. So that is my intention. So aptly starting with basics of machine learning, we'll go into the deep learning, then the basics of deep learning. So what are all the basics of convolutional neural networks? I told about machine learning, I was sticking on to ANN, and when I'm sticking on to CNN. So we'll see what are the basics of convolutional neural networks and what are the popular CNN models, and before the different layers of a convolutional neural network, and what are the different CNN models, AlexNet and all. And what is the first thing you need to accomplish when you want to do a project in digital image processing, machine learning, and deep learning? So today's session is mainly concentrated on digital image processing perspectives in machine learning and deep learning. So initially we cannot understand we cannot go directly into deep learning without understanding the basics of machine learning. So for a student perspective, right from a student who is starting to do a final year project, so he may also have some takeaway from today's session. And also someone who is pursuing the PhD, they may also have some perspective from today's session. And also experienced professors. What I have done as a research, I would like to showcase something. In the final session is how to do the implementations in Python Nowadays, the implementation with the MATLAB and the machine learning is somewhat out of trend. So we have to stick on to Python-based coding for deep learning research. So basically, we will see what are the libraries in Python to digital image processing, machine learning, and deep learning. The implementation of deep learning. So use data set called MNIST handwritten characters. That is a starting point of your deep learning research. So I will tell you that any deep learning algorithm that should be first tested on MNIST algorithm, MNIST dataset. And after that, I will also try to explain another code of deep learning based segmentation of optical disc and optical top. That is my research area after intermediate. I was automation of glaucoma, diagnosis of glaucoma with Tabular transform that I completed with MATLAB and Tabular transform. So now I am going into the deep learning. So diabetic retinopathy diagnosis, glaucoma diagnosis, I am parallel taking into. So where optical disc and subsegmentation from complex images is one of the thrust areas where you can concentrate on your research. And also one more project. So totally taking everything is talking on the image processing aspects. I would also try to showcase some data set, tabular data set. This is a data set that gives the death of 19 patients. The patients already infected with COVID. So MS Excel data set is available that is developed with national database of drug prescription. So that includes COVID severe and other clinical parameters like BP, heartbeat rate. So all those parameters, diabetes and even disease parameters are also included. All these based on these parameters, how can we estimate the probability of livelihood of a patient with this COVID-19? So those projects also I try to time permits. So this data set was used in the paper called Prediction of Death Status on the course of treatment in SARS-CoV-19 that is published in the journal Computer Methods and Programs in Biomedicine by some other authors. Okay. So that is what is the session for today. I would like to introduce on the basics of starting with the ML and the backpropagation neural network, something to learn about the artificial networks and what is supervised learning and what is based unsupervised learning. Then and there, wherever required, I would touch on the textbook concepts also and thereby explaining the implementation perspective. When you want to implement, so today I have named it as implementation perspectives in the sense certain theoretical aspects I would not go in detail. I would just touch upon that and I would mainly concentrate on the implementation perspective, where you have to be careful when you are doing the coding and how to implement whenever you are implementing, or how much should be the number of layers, the layer, all that we discussed. That's what I named it as the implementation perspectives. And coming to the basic thing, first session regarding the AI in ML and DL basics. After that, deep learning basics. So those two sessions will complete before 3:30. And after 3:30, we can go for the implementations. So AI, ML, and DL. So AI is the entire thing. AI starts from the when computers mimic the human intelligence. Okay, it resembles, it takes a decision. When the machines take some decision, that is to be artificial intelligence. That can be right from simple if-then rules. If-then rules done in a simple program, ranging from that to deep learning. We call everything as artificial intelligence. Whereas machine learning is a subset of artificial intelligence, which involves some of the core engineering knowledge. For example, if you are in electronics and communication engineering data, so electronic related information and communication related features have to be extracted. Suppose we are in civil engineering, we are automating some process in civil engineering. Based have to be extracted. So those core domain based knowledge has to be implemented and those features have to be extracted and those will be given to machine is what is the limit of artificial neural network where a strong knowledge is required. That's what I would like to put it upon. A strong core knowledge for engineering of a particular substrate. Clinical data clinical parameters are so clinical parameters extract. For example, I told like glaucoma. If you want to find out the glaucoma from human eye, so we would like to segment the optical descent cup, segment the optical descent cup and find out the cup to disk ratio. Likewise, the field related information are being fetched, and that is what is your machine learning. Machine learning in the sense you have to concentrate on the core engineering based features have to be extracted. And coming to deep learning, which is a subset of machine learning. So sometimes the deep learning algorithms, programs, they are also called as machine learning. Why? Because it's a subset of deep neural networks. So the neural networks that are used in artificial neural networks in machine learning, when they go very deep, The number of layers used are very, very deep for extracting more and more features for big data. That is also an important term. Big data and compared the data, volume of data that we are going to use for deep learning is very, very high. For example, a machine learning project we are doing with 200 to 300 images in the sense. For deep learning, we have to look into up to 30,000 or 40,000 images you are taking, and that is what is the power of deep
Raja,
learning, enabling big data process. Yes, sir.
Raja,
Yes,
Raja,
yes,
sorry to
Hemant.
interrupt.
Yeah, tell me, Hemant.
ஆக்சுவலா உங்க
Yeah,
இன்டர்நெட்
please tell.
லைட்டா அன்ஸ்டேபிளா இருக்க மாதிரி இருக்கு. அப்பப்போ உங்க வாய்ஸ் கிராக் ஆகுது ஆக்சுவலா.
Internet. Okay, okay. Right, சொல்லுங்க.
ஓகே. ஆக்சுவலா நடுவுல வாய்ஸ் கொஞ்சம் பிரேக் ஆச்சு.
Okay.
ஓகே.
Okay, Hemant, no problem. If
ஓகே.
there is any further ஏதாவது இருந்துச்சுன்னா please intimate me. I will stop and
அவங்க
take care
chat
of
விண்டோல
another
கொடுப்பாங்க.
connection.
Participants will be giving in the chat window.
Okay, fine.
Okay, thank you.
Okay, please notify me in chat if there is a problem on it. Whoever is organizing. Okay, that's what deep learning is a subset of machine learning where we go for a deep neural net. That is, the number of layers used is more, and the voluminous data you need to account. So, audience, please, I'm audible and it is clear. Any one of you, can you please respond? Hello. Hello. Any student from the host institution?
Yes,
Please
sir.
respond. Am I audible?
Yes, sir. You're audible now, sir.
Okay, Sangeeta, please stop me if something is not correct. Okay, something is not fine.
Okay, sir. Sure, sir.
And that's what deep learning, in the sense, it is a subset of number of data is the input. There is a difference between the actual machine learning and deep learning. So another typical example describing the difference between classical machine learning and deep learning algorithms. So we can see the input is there, handcrafted features. In the sense, features are very much essential when we go for machine learning. Whereas in deep learning, we don't have that much of domain specific knowledge. We take the inputs and we just do the same operation for any type of image or any type of data. So convolution layer, maximum layer. Likewise, in deep learning, several layers are there. So those layers and those operations are done on the particular inputs to classification. So what we are going to do in this ML and DL in this, we are going for some classification or regression. So classify into several classes. That is what is the ultimate objective is going to be. And starting with the artificial neural network. What is an artificial neural network? As you can see, the human brain, where there are several neurons that are shown as brighter dots. So mimicking this, people have developed, the scientists have developed artificial neural networks, starting from the input node to the output node. So output node, in the sense, that is where the decision is finally made. So suppose, for example, you are going to make a decision to buy a phone or not. So what you can do, you can give several features input from each particular phone. For example, how much RAM it is having, how much internal memory, and how much megapixel camera it is there, and what is the cost also for as an input. For example, you may say this much cost we cannot afford for these little parameters. Likewise, several features of several phones are given, and that are being transmitted to the next neuron. Meanwhile, the weights are being updated. Whatever input feature is most significant, those weights are being updated, and finally the decision is made whether you can whether the particular phone is suitable to buy or not, as 0 or 1. If it is 0, the decision is negative, that you are not going to take that phone. Otherwise, another simple example I can tell that two persons are there. Two persons are telling you something. You are giving nil weightage, almost nil weightage to person one. So the weight that is connecting this input is 0, and you are giving full weightage to the next person. The weightage you are giving to this person is 1. So in that case, what happens? You go and check for the output. Suppose the output is not as expected, the error is there, then error is propagated. Then what do you do is weight adjustment is done. Weight updation is being done. So what is done now? The first weight is being increased, maybe from 0 to 0.2, and the second weight is decreased, maybe from 1 to 0.8. Likewise, the weights are being adjusted. Thereby, how much importance should be given to each particular feature is in an artificial neural network. During the training phase, there are two phases in the machine learning algorithm. There is a training phase and a testing phase. In the training phase, the weights are learned with respect to the input features, and in the testing phase, whatever weights that are already learned. So if you give a new set of parameters as input, so it should be able to classify whether it is affordable or it is suitable or not. That is what is your machine learning algorithm. I have told a simple strategy. The weight is being reduced and the weight is being increased. The accuracy is not like that. There are several optimization algorithms to optimize the weights based on different situations. So that is what is an artificial neural network. And then importantly, when you go for a machine learning or deep learning based project, you need to know what is linearly separable or linearly non-separable. What is a linearly separable data? As you can see here in the figure, if I make by two sets of data, I simply draw a simple threshold for pass. Okay, if more than 50, it is pass. If it is 50, it is. If you are able to draw a line segregating the two of two classes, then it is a linearly separable data. So y is equal to mx plus c, the equation defining straight line. If you come for a machine learning perspective, it will be taken as y is equal to wx plus b, where w is nothing but the weights and b is nothing but the bias. So these weights are iteratively learned by a machine learning algorithm, so that what will be the suitable slope for a particular data to be segregated into class 1 and class 2. Weights are being adjusted. Weights are being iteratively learned. As I told in the previous diagram, iteratively and they are modified. And finally, the slope of the line changes. That is what your artificial neural network is all about. In machine learning perspective, it is y is equal to wx plus b. W is the weights and b is the bias. The machine learning algorithm iteratively learns the W's. So the weights are iteratively learned for different inputs. So you are not going to restrict with one input only. Next another input you are going to give. Again, weights are increasing. And iteratively is going to change. That is what for a beginner for machine learning I am telling all these things. And the illustration of a linear non-separable data. I told about a separable data. So all this machine learning and deep learning are not for linear data. They are suitable and they are only the linearly non-separable data are eligible for machine learning or deep learning algorithms. Linearly separable data is not at all does not demand the machine learning or deep learning at all. So what is the linearly non-separable data? If you look at this, there are several colors. You can take the second figure. Blue color dots are there, yellow color dots are there. Any line that is drawn cannot segregate between these two types of data. So what has to be done? So this is called as a linearly non-separable data. So what is the solution for this? Or what a machine learning or deep learning algorithm is going to do to classify these type of data? The activation, that is one of the important function in artificial neural network. The activation function in AI and artificial neural network are convolutional neural. Artificial neural network connects to machine learning. Convolutional neural network connects to deep learning. So both has the activation function, which is of course very important mathematical function in artificial neural network. That is not given that much importance, but anyhow they are very much important. So they transform the linear space into a non-linear space. The space is being a simple low-dimensional space. This is being transformed into a high-dimensional space where the data can be segregated class 1 and class 2. Suppose you can think all the blue dots are pulled upwards. You are giving another dimension itself to the data. Okay, so all the colors are being visible here. No, another dimension is given to the data in the sense the blue dots are pulled upwards, yellow dots stay downwards, so that you can perfectly draw a plane that is classifying or segregating between the class 1 and the class 2. That is what about linearly separable and linearly non-separable data. So machine learning algorithm is demanded only for linearly non-separable data. And of course, you need to know what is supervised learning and unsupervised learning. Supervised learning in the sense, for example, the first example I told, when I told example for making a decision to purchase a phone, several features are given as input to an neural network. So this is feature one. Likewise, that is a very simple example I told. Any particular data you take, for example, it may be image also. The image one is there. For image one, you are taking 7 features. So these are handcrafted features in terms of machine learning, or it may be normal features in terms of deep learning also. So these features are extracted from each image, and that is already labeled as class 0 or class 1. The domain specific is already labeled it as class 0 or class 1. So this is what is called as supervised learning. What is supervised learning in the sense? These features belong to class 0, saying that is said to be supervised learning. These features belong to class 1, saying that is said to be the supervised learning. So the class label should be given. That is what is called as supervised learning. So these terminologies are also very important to start research project work in machine learning and deep learning. X-train and Y-train. So this is a training. First, what you do to a neural network, input features, and the weights are being learned for each feature, and whether the neural network is able to classify properly or not, it test in the testing phase. In the testing phase, the weights are being learned. This to be the training phase. So during the training phase, whatever the features, input features, they are said to be X train, and whatever the class labels, they are said to be Y train. Next, the testing phase. In the testing phase, what you do, I'm not going to stop. I'm not going to stop after teaching to the students. After teaching, what I will do, I will conduct an exam whether they are properly performing. So similarly, whatever artificial neural network I have trained, so that has to be tested with some images. So from those images also, same features I will extract. Same features, same formula I will extract, and those are fed to the predicts. So this is a prediction. The algorithm predicts class 0. The actual ground is also class 0. Then there is no error. Suppose my algorithm predicts as class 0, but the ground truth is class 1. Then there is a error. This is what is said to be a supervised learning. So ultimately, the error is based on the difference between the weight test and the weight test. So weight test is the ground truth. You are the weight train and weight test, both are said to be truth is given by the domain specific people. For example, if you are dealing with medical imaging, doctors are going to say whether it is a normal image or abnormal. That is already stored in the data set. So you can get it from the data set whether it is into class 0 or class 1. So training phase and testing phase. X train, Y train, X test and Y test. X train is the of the training. Y train is the label of the training data. X test is the input features of the testing data, and Y test is the ground truth of the testing data. And Y print is nothing but our algorithm. This is what is based supervised learning. And next time I discussion on supervised learning, suppose taking for an image processing project, if you want to identify a human face, the intensities and textures at these regions, they can be taken as input features, and that can be filled up as a training feature. Suppose you take another face, whenever the camera, CCTV camera is installed, a sequence of image frames, video sequence. So in that video sequence, whenever a face is detected, only these points will be detected, and the algorithm is able to tell whether the face is detected or not. Similarly, coming for medical imaging, so this is diabetic retinopathy affected images. So for these regions which are affected by disease, those particular intensities will be extracted and given to the artificial neural network. That is what is your machine learning algorithm. So going into somewhat deep into the artificial neural network with respect to equations and all. So somewhat little bit we need to learn. Otherwise, the entire concept of implementation we cannot understand without some mathematical perspective. So this is nothing complicated diagram. So a very simple diagram, whatever neural network is shown in the very first slide. Diagram is taken along with some mathematics. I'll finish off anyhow the mathematics within 2 to 5 minutes. So no need to worry. So this is artificial neural network. The input features are shown as x1 to xn. So I is equal to 1 to n inputs we are taking. So these are the features. And your artificial neural network consists of a layer and the output. Ultimately, the output layer should have the number of neurons or number of that is equal to the number of classes you want to classify. That is output node, number of output nodes. And what is done now? The weights are being I told no. So what is Vij? Ij is the weight connecting I the input j the output node. So that is how the calculations are being made. So net input to the hidden layer. So net input to the hidden layer in the sense it will be the sum of summation of all the inputs xi's. So x1 is coming here, x2 is also coming to xn is also coming to this node. For example, I want to calculate the net input to this node. X1 is taken here, x2 is taken here, and also xn is also taken here. It is correspondingly multiplied with the weights. Bij is the weight. For example, from here to here, it will be V11. From here to here, it will be V21. From the node to the first hidden node. Likewise, inputs are calculated for each of the hidden node. So here also it is calculated. Here also it is calculated. So here means j will be equal to 1. Here means the j will be equal to 2. Likewise, it is calculated. Qij is calculated added with the bias. So you know the equation for a straight line. Y is equal to mx plus c. So m is nothing but the slope of the line. That is nothing but the weight of a neural network. Weight that is iteratively learned. If you come and compare with the linear algebra, that is nothing but a slope of a line. Y is equal to mx plus c. C is a constant that is going to dictate the location of the line. Just like I told, y is equal to mx plus c. The slope m will give the slope of the line. The term m will give the value in the slope of the line, whereas c will give the location of the line. The line has to be based here or here. These things are being adjusted and learned by artificial neural network. And similarly, after that comes the important thing. So input to the hidden node we studied, and what is the output of the hidden node? It consists of something called as an activation function. So what is the main activation function? Where f of denotes a non-linear function. What is that activation function? That activation function is going to transform that particular low dimensional space to high dimensional space for the input features. So they are going to be transformed to a higher dimensional space. For example, in a lower dimensional space, everything is mixed up. So that has to be transformed to a higher dimensional space so that the data becomes linearly separable. So linearly non-separable data it is. So the activation function is a particular parameter that is going to transform this to a linearly separable space. And that is what you can take any textbook on artificial neural networks like Zaruda, for example. This is very complicated mathematics. It's almost like a unit. So I'm simply explaining everything in terms of simple mathematics that can be taken within a short duration of time. So net input to the hidden layer we saw, and output of the hidden layer also we saw. Similarly, the calculations net input to the output layer and output of the output layer is also there. So the same calculations, same physical concept applied to the output layer also. And finally, in the output layer, there is another activation function. Finally, we have the output yk. What is that yk in the sense? Here we study now yk is nothing but my algorithmic prediction. So based on all these calculations and weight adjustments afterwards, is predicting the value we predict. So I hope the connection is clear now. Can the student respond? Is it going? Meeting host, can you respond? Okay. And some more important steps. There is what is back propagation? Back propagation in the sense the difference between y train and y test. Y predict and y test. So this is called as the error. What is the error? What is the prediction by my algorithm, and what is the prediction that is actually there? You subtract what is said to be there. So here we have the same concept here. So this is my y predict. This yk is my y predict, and this is the ground truth. So that is being subtracted to find out the error, and the weight is updated based on the error calculator. So that is what is called as the gradient. That is where the gradient descent optimization comes into picture. So what has to be done? So what is by gradient in machine learning? So in image processing or any other field, gradient means some other may mean some other different parameter. In machine learning, gradient means dou E divided by dou W. That means rate of change of error with respect to weight. So what is my expectation? As I change the error, sorry, as I change the weight, error should decrease. When I change the weights, the error should get decreased. That is what is said to be the gradient here. So gradient descent algorithm, the gradient should get reduced. That is what is the whole theme we are going to take into account. So weights are being updated. How they will be updated now rate into error. So this error is but the difference between the algorithm prediction y predict and y true. Y predict is the algorithmic prediction and y true is the ground truth. And that is error calculated, and we have the learning rate with which the weight is being updated. So there we have the optimizer called gradient descent or any other optimizer you can take that modifies the weight in a direction that should reduce the error. So these three are also important. So whenever you want to learn about the machine learning and put your hands into the machine learning, so study about. So here I have simply told you have to look into the broader perspective about what is back propagation and what are the weight update algorithms available. So optimization algorithms available. Here I have told even a simple concept or a simple concept. You have to go through it in detail. How the error is calculated, how the weight is calculated, and how the weights are being optimized. Weights are being optimized in a direction which reduces the error. That is what is called the gradient dou E divided by dou W. So that is what your machine learning is all about. With all these basics, now we come to deep learning. When you come to deep learning, we have to take about convolutional neural networks. So in a convolutional neural networks, what are the different things or different layers we are going to see? So convolution neural network consists of convolution layer, activation function, as we already know. So here the convolution layers will act upon as extractors. So here you can see one more thing compared to the artificial neural network. This is a convolutional neural network. When you look at into a convolutional neural network, here the entire thing is in structure. So somewhat layers are the convolution layers. So convolution means what you know. Convolution is nothing but extracting features by the process of convolution. So convolution layers, several convolution layers and several convolution filters are being used here to extract features. And finally, we have the fully connected layer. The fully connected layers are those layers which resemble where the actual learning and the weight tuning is being accomplished. So look at convolutional neural network. So these are the layers. These convolution layers are those where the feature extraction is accomplished. So initially itself we discussed not like your machine learning. The deep learning is not going to take into much of the core domain engineering knowledge. So here the core domain knowledge is not that much incorporated. Here a general set of filters are being used for any type of problem. Okay, that may be the case. Okay. So whatever up to my knowledge and learning. So convolution layers are used to extract the features, and the fully connected layers are used for training. So this accomplishes the task that is accomplished by artificial neural network. So convolution layer activation function. In detail, we will see what are all these. So convolution layer is there. So what is done in convolution layer as per formula it is given. So as of now, I'm going to explain the formula. Because what is convolution layer, everyone may know, DC background may know. So for example, if you take an image, so this is a convolution filter. So several convolution filters are there, we told. In a convolution layer, convolution filters are there. What those convolution filters are going to do, the convolution filter is going to be operated on each location of the image, and then the values are taken element-wise multiplication. So this is actually the sum of products. So 1 into 1, 2 into 1, plus 4 into 1, plus 5 into 1. Likewise, if the sum of products is taken, this will give 12. And next where I should do, that is striding. The striding is 1, next I will go to immediately to the next pixel. The striding is 2, I jump out of 1 pixel. That is what is that. Is that is another important parameter called as striding. So here the values are being extracted. So this is a simple low pass filter that is shown. The low pass filter will only give a average information of the particular image. It is not going to give the significant edge information. This is average information given by the low pass filter. When you take a high pass filter like this, high pass filter is nothing but a combination of positive and negative values. When a high pass filter is being applied to an image, popular in image processing testing the machine learning algorithms and image processing algorithms. When this particular high pass filter is applied to a Lena image, we are able to extract the edges, the two horizontal edges of the particular image. So likewise, extracted by those convolution layers present in a deep learning framework, and all those features extracted by several convolution layers, that too having several convolution filters. In each layer, there will be 30 to 30 filters you can declare. All is based on programming. We are not going to declare the value of filters and all in the deep learning framework. So if you say 30 filters, if you say 60 filters will be taken and they will be operated. This is what is your convolution layer. Feature extraction. Importantly, feature extraction is all about the convolution. So a retinal fundus image is there. If you subject this retinal fundus image to high pass filtering, what happens? How the edges are being extracted, that is shown. So that is what your convolution layer is about, extracting the edges. So as I told, so much of features are there, so much of features are there, so much of filters is there. So we have to do max pooling to reduce the redundant features. I want to reduce the redundant features means max pooling is being done. What is the max pooling is? So after convolution layer, we have the activation function. So as I told, the activation function is nothing but to add some non-linearity to the data under classification. The data under classification is simply linear in a low dimensional space. It has to be converted to a high dimensional space. The activation function also presents the essence of the entire data. Like if you have a fruit, if you drink the juice gives the essence of the entire fruit. Like activation function gives the essence of the entire data. Otherwise, the data is entirely presented. So, for example, what are the typical activation functions that were used in machine learning and what is used in deep learning? We will see. So, these are the activation functions that are used in machine learning. Sigmoidal activation function, the values ranging from 0 to 1. And the tan H activation functions were also used in machine learning to convert from low dimensional space to higher dimensional space where it can be easily classified. So the input features, what are all extracted by the convolution layer, they are subjected to this type of activation function. As you can see, these activation functions are said to be saturated. What is by saturated in the sense? After a certain range, more change in the input is not producing much change in the output. So this is very much higher change in the input, for which equivalent change in output is not accomplished. So this is called as a saturated activation function. Saturation in the sense, you know what is the meaning. Similarly, this is also a saturated activation function. There is a problem with the saturated activation functions, particularly when it comes for deep learning. So for that purpose, we take ReLU is the most popular activation function for deep learning algorithms. So ReLU is unsaturated, means in any range of the input, the output keeps on increasing. That's why it is being preferred. So what is by that? Why that problem occurs with saturated activation function in the sense? We have something called as vanishing gradient problem. What is by that vanishing gradient? As much as possible, I am trying to give the essence of what is by deep learning. So I am skipping to one concept to next concept. So how much ever possible you can take it, and you can also make a note of certain things, and also you can refer it in detail later. Okay. So I'm discussing so much. I started with machine learning. I'm going through deep learning. For those people who are already familiar with all these things, it may be simply a revision. But for those people who are just now touching machine learning, so whatever I am telling is somewhat in detail. Okay, they can at least note down the headings and they can have an elaborate think of and study in the later things. Why? Because when you want to put your hands on your research, these are all the essential things you need to know. So if you know all these things, you can start a project in machine learning or deep. So that's what the vanishing gradient. What is by vanishing gradient? Whenever I spoke about the optimizer in the artificial neural networks, the optimizer is nothing but the gradient dou e divided by dou w. That is rate of change of error with respect to rate of change of weights. So what is the ultimate objective of the weight change? Weight change should change the error, should decrease the error. So the optimization algorithm, what it will do, it will move the weight in a direction so that it gets reduced, or even the thing dou e by dou e entirely should get decreased. So the weight change should accomplish the change in error. That is what is the gradient descent algorithm or optimization is all about. So what is meant by the vanishing gradient? As the name itself implies, a vanishing gradient in the sense, as we have in a deep learning, more and more layers are being accommodated. When more and more layers are being accommodated, what happens? So this is a particular forward pass of a artificial neural network or a convolutional neural network. In the forward pass, the weight update is being, whereas the error is being back. When the error is being back propagated, what is dou E divided by dou L is a loss function or error you can take. So dou L, what happens now? It is by a chain rule. So this dou L divided by dou Z will be taken to the previous layer also during the calculation of the gradient. So that is dou L divided by dou X. Suppose this is the next neuron, this is the previous neuron, and this is another neuron. So whatever is the gradient in the next stage, also multiplied here. This is called as a chain rule. So whatever terms I am telling, if you are not familiar, if you are a new person to put your hands on machine learning, these terminologies, if you learn, you can just start a project in the deep learning or machine learning, and then you can start simultaneously. Nowadays, because the question is whether I should learn all those textbooks concepts and then go into the deep learning or machine learning, or I should start working into the project and then I can simultaneously learn now. Something minimally you need to learn before putting your hands into your project. So that minimally what you need to learn, that is what I am telling you. Okay. So if you are not able to completely understand everything, you are new to these areas, you can just note down these topics and study all these topics. Whatever I told, maybe giving you some insight into what is all these. So that being accumulated as a error background. So what happens whenever the gradients are becoming very, very low? For example, this value is 0.2. This dou L divided by dou Z is 0.2. Dou Z divided by dou X. Dou Z is another change of weight. Dou X is another change of weight. Only this is error function. And this is again error function. To calculate the error function of the previous node, the error function of the next node is taken into account with respect to multiplied with the change in weight of the output node divided by the change in weight of the input node. Whenever this happens, whenever this the dou L divided by dou Z is very small, maybe for example 2, 0.2 into 0.2 when it is getting multiplied, that is going to be further decrease the value. So 0.04. So what happens ultimately? The gradient will vanish. The gradient will become very less in magnitude. So what is going to happen now? The weights will lose its control over the error. So it cannot decrease the error. So that is what is said to be the vanishing gradient problem. Why? Because these saturated activation functions are not much changing the output. After a certain range, it is not much changing the output. That's why the vanishing gradient problem occurs. So what we have to do now, for a deep learning algorithm, we have to go for unsaturated activation functions like ReLU. That is deep learning algorithms where the number of layers are very much limited. There the chain also limited and there is not going to be a problem of vanishing gradient. But ultimately learning and the layers are very much more in number, this vanishing gradient problem is going to be very big. That is why for particularly for deep learning, we go for unsaturated activation function like this. So first of all, what is the activation function? So when you come back to a convolutional neural network, basic convolution neural network, we have convolution layer, max pool layer. Convolution layer is going to extract the features by means of filters. So every convolution layer is going to have several filters. 30 filters you can declare in coding, 60 filters you can declare in coding, like this you can declare. And the max pool is going to reduce the number of features, redundant features it is going to reduce, I told you. In between convolution layer and max pool, even though it is not shown in the diagram, there is something called activation function. Activation function is very, very essential. That's why when you look at the computing personalities, they very much give the importance to convolution, all these layers and architectures of the convolutional neural networks, whereas the activation function is taken for granted. So signal processing professors and image processing professors, we have the liability to work on the activation function and modify the activation function suitable for different types of data. So that is what your activation function is all about. And afterwards, max pooling layer. So max pooling layer, the mathematics is again very much complicated, but simply if you see, so too many features, typical, so many convolutional filters are used. There is always a repetition of the convolution layers also. So there, what happens? So much redundant data may be accumulated. So for that burden, what we are going to do now? Max pooling is done. What is max pooling now? For every even sized window, the maximum value is only retained. If you look at this, 9 is only retained. If you look at this, only 8 is a simple process called a max pooling. And finally, the fully connected layer. As I told, the fully connected layer resembles the artificial neural network where actual weight change or learning is being accomplished. So for whatever is being explained, I'm just rolling it down. So what is by AIML DL we studied? So if you want to put any inputs to me, you can talk. Else I can understand everything is going fine and I will continue. This is what we have been looking into it today. So when I explain some coding part, these terminologies are very important. X train, Y train, X test and Y test. So these are basic things need to be machine learning. After completing these basics, what I told, this is the algorithmic prediction. The algorithmic prediction, that is Y predict compared with true. Predict is the algorithmic prediction, Y2 is the ground truth that is given by the domain experts, and that is said to be error. So that error has to be back propagated. Error has to be back propagated. During the course of back propagation of the error, optimization algorithm comes into picture. For example, gradient descent algorithm. The weight should be adjusted in a direction that reduces the error. So dou E divided by dou W gradient. Change of weight should reduce the error. And this is what is your machine learning part, an artificial neural network. And afterwards, coming to the deep learning part, we discussed only few layers. Since we discussed the complexity of all the algorithms of back propagation and what is a gradient descent, everything we discussed in the ANN part itself, the CNN part or deep learning part became very simple for us. We just noted what are different layers: convolution layer, maximum layer, and activation function, fully connected layer. Layer resembles the artificial neural network, the fully connected layers of the artificial neural network, where the weight change can be accomplished. The fully connected layers. So I just told comparison between ANN and CNN like that. So in the entire CNN, the convolution layers and max pool layers, they are going to extract the features. The actual learning, the feature extraction. So if you look into closely, CNN also comes into the framework of feature extraction and classification. So I told the activation functions are used after the convolution layers. Likewise, softmax is the activation function finally used. Why? Because softmax gives probabilities of each class. So after the fully connected layer, suppose if it is a 3-class classification problem, you have 3 nodes at the output. So 3 nodes are there at the output. So it should give the probability. The activation function should give the probability of all the outputs. That is essentially the t should sum up to 1. That means if the probability is 0.7, 0.2 and 0.1. If you sum up everything, it should be equal to 1. That's why we go for a softmax activation function at last. So these are the important points we need to know. So finally, if you use ReLU here, ReLU is the activation function used here. But after the fully connected layer, we won't use ReLU. Why means softmax is the activation function that gives the probabilities. If you go for a 10-class classification problem, finally 10 nodes will be there. In all the 10 nodes, function used will be softmax. So we essentially learned about the different layers. When you come to deep learning, what are the different layers is the primary question. So convolution layers, activation function, max pooling layer. And interestingly, next we will see some of the popular architectures of convolutional neural networks. What are the popular neural network architectures? So this, whatever we have seen just now, it is said to be AlexNet. This particular convolutional neural network is said to be AlexNet. So regarding AlexNet, it won the ImageNet competition. So ImageNet is a data set. So sometimes it's a confusion. AlexNet is a neural network, name of a neural network. ImageNet is a data. So on the data set, some competition being held, and AlexNet won the competition in 2012. That's why it became a popular convolutional neural network. It is a very simple convolutional neural network. So we talk about deep learning. So even we talk about deep learning, the AlexNet is not too deep. So it consists of only match pool layers overlap with the stride of 2. What is by stride? When you do the convolution, how much is moved? That is to be stride. So in fact, this is the first CNN using ReLU as an activation function. So because of using ReLU, which is a saturated and unsaturated activation function, which are very much suitable for deep learning, so accelerated the speed of the training process by almost 6 times. When ReLU was used, the speed of learning was very high. The AlexNet. So two fully connected layers are there. We are typically explaining this particular AlexNet. Two fully connected layers are there, and finally softmax activation function is used, which produces a probability maps in the range of 0 to 1. So for each class, you should give the probability in the range of 0 to 1. For which case, this diagram will be easy to understand. This particular ANN diagram compared to the CNN diagram, ANN is showing the number of output nodes. So the probability should sum up equal to 1. That's why we use the softmax activation function. So that is what is your AlexNet is all about. Since it is though it is a deep learning algorithm, it is not too deep. Okay, so to extract, to go for more accuracy, we have to increase the number of layers. Then came into the pictures called VGG net and Google net. Since AlexNet, the state of art CNN architecture is going deeper and deeper. Afterwards, the trend of research is being increasing the number of layers. So nothing novel like modification of algorithm or any signal processing aspects. Nothing novel like that. So the trend of deep learning research has been going like increasing the number of layers and modifying the architectures. Likewise. So after AlexNet, the VGG net and Google net, they are having 19 layers and 22 layers respectively. What's the problem increasing the network depth or number of layers? When you go on increasing the number of layers, what may be the problem means? The problem is already, as already discussed, the vanishing gradient problem. So two things happen. The weight learning in the forward direction happens, and the error back propagation in the backward direction also takes place. When the error back propagates, if there are too many layers, the gradients will vanish. The gradients are nothing but the rate of change of error with respect to rate of change of weights. So this is dou E divided by dou W. Weights I say in general as W, but this is one weight called Z. This is another weight called Y. This is another weight called X. So what happens whenever the dou E divided by dou W in the previous layer is accumulated by chain rule when you calculate the gradient in the next layer, the previous layer, then what happens? The gradients will decay the gradients. This gradient will become very, very low as the network goes deeper and deeper during the back propagation, and when you're coming back for a longer, deeper layers, the gradients will get vanished. There is a vanishing gradient problem. Already that vanishing gradient problem is addressed by unsaturated activation function like ReLU. But anyhow, if the network depth is further increased, deep networks are hard to train because of the vanishing gradient problem. What is by vanishing gradient problem is written here. Two times very. That is what during error back propagation, each layer has a divided by W. Here the gradients backwards. So the gradients which are very less. Repeated multiplication of smaller values make the gradients infinitely small. As a result, as the network goes deeper, its performance gets saturated. Performance gets saturated in the sense. So AlexNet is okay. AlexNet is not that much deeper. So if we keep on increasing the convolution layers, max pool layers, like here only 3 layers are there. You increase to 100 layers, you increase to 50, 60 layers. So what happens? Vanishing gradient problem will occur. one solution is offered by something called as ResNet. So this is the architecture of the ResNet, which has skips. So this is 34 layer residual ResNet. There are very many versions of residual ResNet. So the number of layers is very high. Again and again, convolution layers are there. How many filters are there? 64 filters are there. When the network is going very the vanishing gradient. So what is done to address the problem? The skip connections are established. So what the skip connection do now? During the error back propagation, it offers alternative paths for the gradients, so that the gradients will not vanish much. The gradients are kept alive by the skip connections. That is what is the ultimate solution offered by the residual network for the vanishing gradient problem. Figure shows a 34 layer ResNet which has skip connections. There are many editions of ResNet with number of indications. With number indication, the number indicating the number of layers. So 34 layer ResNet means it has 34 layers. The skip alternative path for the gradient vanishing. So whatever it is I told, that is what is your ResNet. So as of now, I told 4 sessions. I am going to the case I have divided the entire lecture into 4 sessions for my own convenience. That is first about the artificial neural networks, the second one about the deep neural networks, the third session about the data set, and the fourth session about the coding perspectives. So 2 sessions are being completed regarding the machine learning and deep learning. Next, we are going to talk about the data sets, whatever the data sets we have for these ML or DL projects. So those who are entirely new for this type of discussion, this particular field, they can have a view of all these things what we discussed. So what is base CNN? What are the different layers in CNN? This is a typical CNN called AlexNet. So convolution layer followed by activation function, followed by max pool. So any other CNN architecture may have additional layers. I mean, these are the basic layers to be a neural network. A convolutional neural network should have. The basic layer should be convolution layer, max pool layer, dropout layer also there, which is not discussed here. And finally, fully connected layers. In fact, the weight adjustments are being done here. So this is feature extraction. The convolution layer extracts the features. That makes the difference between the machine learning and the deep learning, artificial neural network and the convolutional neural network. Name itself implies convolutional neural network. So you have convolution layers. Extracts the features. So this is feature extraction and afterwards classification. Convolution operation is being implemented on an image. And the output is like this mathematically. The convolution filter is operated on a Lena image. So what I told, this is a low pass filter. Why? Because all the values are same. The two particularly one. That is a low pass filter. Low pass filter gives the average content, average energy present in a neighborhood of an image. Whereas high pass filter will give the high frequencies that are nothing but the edges. Edges in an image are said to be high frequencies. Similarly, a retinal fundus image and its high frequency information. And importantly, activation functions. Mathematical part is activation functions. Converting the data after the features are extracted by convolution layer into a high dimensional space. The activation function gives the essence of the data. The difference between taking a fruit and its juice. You take a juice, the complete essence is being taken. Likewise, you need to extract the essence of the data in the sense. You need to transform it from a lower dimensional space to a higher dimensional space. That is being accomplished by the activation functions. In machine learning, we accomplish the activation functions. The activation functions get saturated. That is, after a certain range, the more change in input does not accomplish much change in output. These are saturated activation functions which produce vanishing gradient problem when you go deeper. So for the deep architectures, being first proposed in Alex, which won the competition of ImageNet, which won the competition using the ImageNet dataset. So particularly ReLU is reported to accelerate the speed of learning. That's what we saw. So this is a simple action. And the ResNet is something which offers much deeper architecture. So the ResNet 34, ResNet, several numbers are there. So the number of layers are given by the ResNet name, ResNet 34. So what is given now? The skip connections. The skip connections offer alternative paths for the gradients to back propagate during the error back propagation. And afterwards, you see what is the first thing to accomplish after learning all these basic theory material. What we need to know, that is, data set is the first point to accomplish. So what is my data set? I want to, by means of a machine learning algorithm, that is it to be a data set. Most of the data set are called as gold standard data sets that are available in the internet. So you have to check with the publications. Whatever publications are coming in the area which you need to, which you intend to do the research here, those data sets are being referred in the papers or not. So as I already told, MNIST data set is the starting point of your deep learning. So any algorithm see here, MNIST be thought of as the hello world machine learning. So that means hello world is the starting point of any coding algorithm. You code it to say as hello world. There is a starting point of any code you see or what. So likewise, hello world of machine learning is MNIST. It is primarily used to experiment with different machine learning algorithms. Any machine learning algorithm is first experimented on and to compare the relative strengths. So suppose two different algorithms you are developing. So you can test it on MNIST dataset. MNIST is often the first dataset researchers try, and ML researchers say if it does not work on MNIST, it won't work at all. That is the simplicity of MNIST dataset. So here you cannot categorize this into X train, Y train, X test, Y test, and all. It is already being categorized into same. So with a single line of command, you can have the training dataset and testing dataset. So though I am saying this is the first thing to accomplish, you are going for a hands-on workshop which ends with MNIST. That means it is not that much valid. Means you have to learn with real-time data. In fact, the learning platforms like Udemy and all conducting courses like beyond MNIST, what to be accomplished in deep learning. So if you go to real-time data only, you can understand something. So what is this actually MNIST dataset in the sense? It is handwritten characters used for supervised learning. 70,000 handwritten characters are there. These are black and white images, each of size 28 by 28. There are 9 classes. Should be in fact 10 classes. Starting from 0 to 10 is 10 classes. A 10 class classification algorithm can be designed. In fact, model can be defined. Any model can be converted into a 10 class classification model or whatever it is. You change the number of nodes in the output node, last output node, that becomes, if you have neurons in the last output node, that becomes a 10 class classification problem. If it has 3 neurons in the last output node, that is a 3 class classification problem. Likewise, you cannot always tune to that. That is why any machine learning algorithm can be developed and tested with the MNIST algorithm. Particularly when you go for image processing, this MNIST is the help. So after MNIST, what else is there? Fashion MNIST. Fashion MNIST is developed as an alternative for the original MNIST dataset for benchmark learning algorithms. Again, for benchmarking the machine learning algorithm, some other datasets we need that is given by the fashion MNIST. Dataset given by Zelano's article consisting of 60,000 training images and 10,000 training images. Testing 60,000 for training and 10,000 for testing. Here also the same case. 70,000 images are there, 70,000 black and white images are there, out of which 60,000 will be used for training and 10,000 will be used for testing. So fashion MNIST is another data set. It is provided by Kaggle repository. Kaggle is a repository that has different image data sets. Image and also other types of data sets are there in Kaggle. It is a repository. And next coming to the real-time data sets I told no. So these are all non-real data sets which are used for in fact developed by itself for testing the algorithms. The Keras library has developed this MNIST data set so that any algorithm developed in Keras or TensorFlow that can be tested with the MNIST data set. So when you come to this type of real-time imaging data sets, so that is also given by the Kaggle repository. The Kaggle repository has fashion MNIST like this. The Kaggle repository has another data set for diabetic retinopathy images. So 35,126 color fundus images are there, encompassing 5 classes of diabetic retinopathy. Diabetic retinopathy in the sense the first image, if you see, it is a normal image, and from image to image, the severity of the disease increases. That is what data set, and the labels are given in a separate Excel sheet. For example, this is a class of the first image. So the images are not kept in order. Inside a folder, all images are randomly placed, and for those all images, what is their label is corresponding to the column of Excel sheet. So when you do the coding, what you have to do now, when you fetch the first image that corresponds to first column of the first row of the Excel sheet. When you fetch the second image that corresponds to second row of the Excel sheet. Likewise, the coding has to be done mapping the particular image with the particular label. That is what is supervised learning in fact. What is by supervised and unsupervised learning? When you go for supervised learning, the label should be given. X-train, Y-train. X-train is the actual data where you get out of a particular image, and Y-train is nothing but its belongingness, what class it belongs to. Likewise, as I told in the Kaggle repository right now, the images, that image corresponding class. So I told in Kaggle repository regarding the diabetic retinopathy database, for all the 35,000 images, the images are kept in a folder where belongingness is given in a search sheet. So I have to code saying that the first image corresponds to the label given in the first row of the Excel sheet. So likewise, the challenge comes when you go for a real-time data set only, because each data set is having its own perspective of maintaining data. That's what. So this is a simple classification problem. Classification problem in the sense all the images have to be learned with respect to the labels, and that is a training phase. In testing phase, out of the 35,000 images, what I can do, 80% of the images I can do for test training. I can take for training. Remaining 20% of the images I can take for testing. So I have to test a particular image now, that what is my algorithm predicting after learning, the weights are being learned, and what weights are going to say for a new image, new testing set of image, whether it is to say as a normal image or abnormal image, for which the ground truth is already there. The ground truth is already maintained in the Excel sheet. So what your algorithm predicts, that is compared with the ground truth. So X test and Y test. So X is nothing but training. X train, Y train, X test and Y test. X train is nothing but the training images. Y train is nothing but the training labels. Again, X test is nothing but the testing images, and the Y test is nothing but the testing labels. So when you do the testing phase, again the images are given and their predictions are being calculated by the convolutional neural network. And after which whatever it predicts, that is said to be the algorithmic prediction. The algorithmic prediction is now then compared with the ground truth. The ground truth is said to be Y test. So those things should be very essentially and importantly known. What is X train, Y train, X test, and the Y test. So I I divide the 35,000 images into 30,000 images for training, and 500 images, 5,000 images for testing, 30,000 for training and 5,000 for testing. I call it as X, and their corresponding labels I call it as Y train. and 4,000 images I take for testing. All those images I call as the X test. What is my algorithm predicts whether it is a class 0 or class 1, class 2 or class 3 or class 4. That is my algorithm prediction called Y predict. And that also the ground truth is there in the data set, in the Excel sheet. That is also there. So then that is being compared. Whether my algorithm predicts class 4 as class 0 or class 4 as class 4 itself, that means no error. So that is what is your data set of Kaggle for diabetic retinopathy. And another segmentation data set is also there, in which is maintained by the IIIT Hyderabad. So there are 101 images, 50 images for training and 51 images for testing. So what this algorithm maintains, it maintains both the original image and also its ground truth. So how the learning has to be accomplished here, the supervised learning has to be accomplished here. Here the weight train and weight test are maintained in a separate Excel, as I told. No, weight train and weight test are nothing but the labels. They are maintained in a separate Excel. But here what happens, the ground truth is shown as another image. So what is the objective of this segmentation? The objective of this segmentation is to segment the optical disc. If you want to segment the optical disc, the final outcome is expected as the optical disc that is at the center should be shown as white. The background should be shown as completely black. So how the supervised learning is accomplished here means each pixel is being learned with a supervised learning framework. This particular pixel should be learned as a background. This particular pixel should be learned as a foreground or optical disc. Likewise, your entire pixel becomes an entity. Here each image is an entity. Your entire pixel itself is an entity. One image is learned with respect to background and another pixel is learned as a foreground or optical disc that has to be segmented as the area of interest. So here each pixel becomes an entity. That is why the total number of images is very less even for a deep learning algorithm. 101 images are enough for training and testing. Why? Because here each pixel is going to act as a. So that is what is the different data sets, particularly concerned to image processing projects. MNIST data set is there, fashion MNIST data set is there. So these are the very preliminary data sets. So when you go for a hands-on workshop, check whether a real-time data set is there like this, excluding the MNIST and fashion MNIST. So when you learn only MNIST and fashion MNIST, and when you come to a real-time data set, it's going to be little difficult. So go for a workshop whichever is dealing with some real-time data set also. And just have a look at the cats and dogs data set. This is also another data set, and have a thought of how it is different from the above data sets. So I'm not going to explain any project on the cats and dogs data sets. You can infer these cats and dogs images are not, these are the cats images. So that is also maintained by the Kaggle repository. So these are different types of research tools. So contrary to the medical image processing or satellite image processing, where the images are very much standardized. Standardized in the sense the particular central portion of the image is occupied by the eye fund, whereas the background is shown in black. So that is what is the area covered in all the images, whereas these are non-standardized images. Different poses the cat images are there. In different poses the cat images are there. You have some hands also. That is what is the cats and dogs data set. So in people develop deep learning algorithms for cats and dogs data set also. And last, we have tabular data sets also. So somebody may have a feeling that I'm talking entirely on image processing. What is a tabular data set? A tabular data set of prediction of death probability. Nowadays, COVID has become the most important problem. So for COVID-19 patients, prediction of for that national database of prescription is being developed in Italy, I think. The data set consists of 1603 COVID-19 patients and 13 variables, means 13 features are obtained, and that is maintained as a developed data set. And in the data used in the manuscript, the course of treatment in SARS-CoV-2 in a journal called Computer Methods and Programs in Biomedicine, published in 2021. So why I am very specific about this journal offers most of the research works with codings. There is existing work is already available in the papers. They give the GitHub link for the coding also. Not all the papers, particularly for this paper, the code is not given. If you want to develop some project, always when you do a research program, you need to implement first the existing method. So for that existing method, the code is already available in this particular journal. So what are those published of the papers, the codings are already available. So discussing regarding this data set, what are the data maintained in this particular data set to predict the death of a COVID-19 patient. The COVID severity, that is almost important, whether it is a mild severity or a somewhat moderate severity or high severity, that is given as a COVID severity. Along with that, the age, gender, diabetes, hypertension, diseases, lung diseases, cancer, renal diseases, whether they are present or not, that is being maintained in this particular tabular data set. It looks like, typically it looks like this. Patient ID is given. For 1603 patients, it is given. So this is somewhat a big data project, not a computer vision project, it's a big data project. So what is the age of the patient? When you take these particular features, almost we can see age is only the quantitative feature, in the sense it is continuous variable, whereas the other parameters are almost qualitative in the sense. Some people think like qualitative in the sense it should be only words like good or bad. So discrete values are also qualitative features. So this is quantitative features and these are all qualitative. Qualitative features saying only whether the person is a male or female. Diabetes means whether diabetes is there or not. So this is another tabular data set where you can do your research, because COVID-19 is very hot topic of research today. So COVID-19 based chest X-ray images are also taken for research. We have not discussed that project now. Already so much of image processing data sets I discussed. So a different data set I take for COVID problem. The COVID severity is given and the death probability is also given a classification problem. Ultimately, the output is qualitative. You call it as a classification problem. So qualitative and quantitative. Quantitative are nothing but continuous variables. Qualitative are discrete variables or not. Sometimes qualitative may be good, bad, like. So in the qualitative and quantitative is there. Consider the output. When the output is qualitative, we call it as a classification problem. So this is a classification problem. When the output is quantitative or continuous, we call it as a regression problem. That's another thing you need to learn when you go for a machine learning. Moderator. Can we take a break and continue after 15-20 minutes? Hello. Am I audible or not?
Yes, sir, you're audible.
Hello.
Sir, can you hear me?
Yeah, can we take a break and resume after 15 minutes?
Yes, sir.
Okay, people, let us join back by 3:40. The time is 3:20 now. Let us join by 3:40. Thank you all.
Sir, your mic is muted, sir.
Can I continue this session?
Yes, sir.
Can you unmute and speak?
Yes, sir.
Are you able to hear me?
Sir, am I audible?
Are you able to hear me? Okay, but I'm not hearing your voice. Okay, we move on with the presentation. So whenever I come to the discussion session, we'll see. So let the people also join. We'll also see what are the data sets. MNIST, fashion MNIST. We discussed about MNIST. That is a database of handwritten numerics from 0 to 9. Ultimately, we ask anyone to write. They will have different styles of different strokes of writing. But ultimately, an algorithm should properly identify or classify that as a particular unit. So for that, the Keras library, machine learning library, has developed a data set called the MNIST. So MNIST is the hello world of machine learning problem. It is a start point. So most of the ML researchers say does not work on MNIST, it won't work at all. That is a starting point. Another benchmarking data set for machine learning algorithms is fashion MNIST. It almost has again 70,000 images with 60,000 for training and 10,000 for testing. So I don't think you can change this proportion. Okay, so whenever we go for coding using MNIST or fashion MNIST, it is taken as it is. We cannot change the ratio for training and testing. So again, 28 by 28 black and white images, grayscale images with 10 classes, 10 types of clothings, male clothings and female clothings are there. That has to be properly categorized. And then we came for some real-time data sets. We told that we have to work on real-time data sets to begin a research work, apart from MNIST and MNIST and fashion MNIST also. So a diabetic retinopathy, as I am an image processing pursuing person, I completed my PhD in glaucoma diagnosis using wavelets. Those time I did in machine learning, ANN based algorithms. Right now we are working in deep learning or CNN based algorithms. So I am using this data set also. It has 35,126 images. When I did my PhD in 2016 or so, I would be testing my machine learning algorithms in 200 images to 300 images. Of course, computing people are also here. They know much better than me. Okay, so when you want to increase the number of images from 150 to 200, so my machine will not be able to support that. Okay. So nowadays, what is the case is we are directly working with 35,000 and odd images, all thanks to the computational facilities offered by deep learning libraries by connecting to Google Colab. So we can connect to Google Colab on the cloud, and we can work with the data set that is on the cloud itself. So you can dump all these images in your Google Drive, and from your Google Drive you can train the images and test the images also. No need to have in the system. So the days are gone that we have to go for a high-end system for doing these projects, machine learning based or deep learning based projects. Right now, I'm maintaining a very low configuration machine that is suitable only for operating with Microsoft Excel and Word and PDFs. Whereas all these are taken care of by the cloud facility given by them. And also, I work on the segmentation based projects. In fact, this is one of the projects done by my students. Segmentation. So it is a simple. We have developed a simple encoder decoder based model. Nowadays, the cutting edge UNet, MNet has come. Why instead of taking MNet and UNet, simple encoder decoder based segmentation I have taken, because this is where the point we can start learning. Directly, if you go to UNet, the Python itself, the coding is directly there as UNet, declaring the number of layers. There is nothing to learn, and there is nothing to put your hands on. So the starting point to learn is this encoder decoder based CNN, which is used for segmentation of images. So for any segmentation, you can take images and their ground truths. The database should be properly available. The first thing I advise for undergraduate students when they come and start an image processing project without any proper data set, they have to take a proper data set which is being published, which is being referred in some of the publications, some of the good publications that they have taken this particular data set. Then we can go for that data start our work also. And finally, we work on the cats and dogs data set. I told the cats and dogs data set are not much standardized data set. So we have been living with a limited set of images. The world has been different. All standardized images looking with the same resolution. But when you come for a cats and dogs data set, people are also developing robust deep learning algorithms to classify these images also. The problem with these data sets are every particular image is having different colors of dogs, and every particular image is having different posture of dogs, different breeds of dogs. So this is where they test a particular algorithms robustness. Whereas my intention is to develop more and more algorithms robust to classify these images with better accuracy of classification. To categorize the 5 classes of diabetic retinopathy, or in glaucoma, I want to segment first the optical disc and optical cup. If I want to go for clinical features, I want to first segment the optical disc and optical cup. So segmentation itself becomes a problem here. So our thought is different. So whereas the other side of the world, they are moving towards any type of image being given. So here having a hand also. Okay. So there are also deep learning algorithms developed to classify these cats and dogs also. Some people are there, they start working like MNIST. They have the cats and dogs data set as a default data set. They simply scratch on their algorithms, they develop new algorithms and they start testing their algorithms directly on cats and dogs data set. It's not a simple thing also. It's another side of the research work. And also this is not particularly restricted to imaging only. Tabular datasets also I told you. Tabular datasets for several types. If you have interest, you can also check in Prima Indian diabetes dataset. So this is COVID-19 dataset. The reason for taking this is somewhat hot research being published in one of the papers in computer methods and programs in biomedicine. So this is one of the hot dataset that is being taken, which is expected to have more publications in the near future. Otherwise, you can also go for Prima Indian diabetes dataset. For diabetes patients, what are all the different parameters being taken and whether they are having diabetes or not. The problem with this dataset is most of the input features are qualitative. So much. When I tested this with CNN, the accuracy is very less. So I have to do some data processing. So then only I can take this for any outcome. So before that, the dataset itself is very uh, much have limitations because the features are very much qualitative. So if you check with this particular manuscript also, they have tested this with not with the CNN. They have tested with the XGBoost algorithm, which is somewhat different. So in that case, this data set is another tabular data set. If you want to work with the CNN and for a tabular data set, you can go for a Prima Indian diabetes data set. That is also available in internet. And for importantly for doing all these projects, what are the Python libraries? So there are so many libraries, completely people available here. They may be knowing much better. Okay. But anyhow, for my objective is to develop a computer vision project, or image processing project, or deep learning or machine learning project. With these libraries, it is sufficient for us to survive. That is NumPy and Pandas library. NumPy is a library that is used to manipulate on arrays and vectors. In MATLAB, we can do any manipulation with matrix and vectors simply, but in here we have to go for a NumPy library. So Python being a freeware, we have to import the appropriate libraries for different tasks. So NumPy library that is used to do with array, vector, and matrix operations. It is best suited for numerical data. Suppose a tabular data is there with numerical data. This itself is not exactly numerical data. Why means I will tell the reason. These are qualitative. So for this particular project, we are going to call Pandas only. Pandas is best suited for tabular data involving qualitative features. I told the qualitative features in the sense that doesn't mean only good to bad. Otherwise, the qualitative features are also discrete values. Discrete values can also be taken as should also be taken as qualitative only. This is not quantitative, this is qualitative. If the values are continuous, that can be taken as quantitative. So these are qualitative features. When you are looking for qualitative features, including some strings like good, bad, average, so data can be better handled by pandas. That is what pandas provides: high performance, fast, easy to use data analysis tools for manipulating numerical data and time series data. It's also suitable for numerical data, best suited for data, qualitative data. Is useful for data manipulation and input. Otherwise, my database is having only numerical data for resizing the tables, for fetching a particular row of a matrix. Likewise, whatever we do in MATLAB, that can be better done by. And Keras coming, Keras and TensorFlow. Keras and TensorFlow are the machine learning library used for data to build, train, and evaluate a model. What is by build? Build is nothing but how many convolution layers I need, how many max pool layers, how many dropout layers, how many fully connected layers, what are the activation functions, how to define that activation function, whether the activation function is a default resolution or you have to go for a custom activation function. Likewise, so many things we need to build. That is model building, used to train the model, evaluate a model. We'll see a sample code how to build, train, and evaluate a model. So Keras and TensorFlow being machine learning libraries. The TensorFlow is also used to build, train, and evaluate a model. It is developed by Google Brain. It is used to develop some complex networks. Much complex networks can be developed by TensorFlow. And OpenCV, CV stands for computer vision. Open computer vision is a digital image processing or computer vision library. It is used to do the image processing or computer vision tasks. It is developed by Intel, used for image recognition and reading. Similarly, is also parallelly another computer vision library. Python library used for transforming image files. So OpenCV and PIL for handling images, Keras and TensorFlow for machine learning. And generally, you want to treat the tabular data or even images. What is image processing? Dealing with matrices and vectors. You look into the actual manipulations. The images are being treated as matrices and vectors. So to deal with matrix and vector operations, you go for NumPy. So these are the different libraries in Python. And more importantly, when you want to scratch upon a project, you need to install Python Anaconda. When you install Anaconda, get a Jupyter. So Jupyter Notebook is a front end used to run all these projects. And also you need to install Open image processing aspects, Keras and TensorFlow for machine learning or deep learning. So what you need to install. Else you need to install Python and get a user in Google Colab. Only install Python and get a user in Google Colab. The notebooks execute code on Google's cloud service. So Jupyter Notebook, whatever you will get by installing it on the Colab notebooks will get to the Google's cloud servers where you can open Jupyter Notebook. And they also leverage power of the Google Lara. That means the cloud space is powered by the Google. So including GPUs and GPUs. And not only CPUs, graphical processing units are also computationally available, regardless of the power of your machine. So whatever may be the low end your laptop is, you install and have a user in Google Colab. If you have a Gmail account, you can get an account in Google Colab. Then you can connect to Google's cloud servers and you can run your Python projects on the cloud servers. So it is what is a Google Colab? Google Colab is primarily created for Google Jupyter Notebook. Yeah, please.
Excuse me, sir.
Yeah, please. Yeah, please. Yeah.
Ma'am,
Professor, I have a query. May I ask?
Yeah, please proceed, madam.
Sir, are these open source softwares?
Yeah, all are open source only. Nothing is licensed. Everything you can get free.
Okay.
Free you can download.
Sure, sir.
Python is also freeware. Anaconda is also freeware. You can install one by one Python, Anaconda, Keras, TensorFlow, and you may be required to install NumPy also. NumPy, Pandas, every package you may be required to install. If you are not connecting to Google Colab. Whereas if you install Python and connect to Google Colab, So only Python you need to install. Everything else is offered by the Google Colab itself. Even the Jupyter Anaconda also you need not install. Only Python and Google Colab will do the job, giving you the power of graphical processing units so that you can process multiple images at a stretch. What is the beauty of this? And I promised that I will show some sample course for MNIST dataset. So I told that the ABC world of machine learning projects by using dataset. We'll see. So there are two codes. So this code you can get almost anywhere in the internet. So I have enhanced that code by using convolution layers. By using convolution layers, how that MNIST dataset is being categorized or classified. So coming for this taking this first project in MNIST dataset categorization of MNIST dataset. It is as simple as the default data set. The default data set. So this is the Google Colab environment. Some of you may be already. So this is a Jupyter. Install Python and Jupyter notebook. This Jupyter notebook can be opened separately in your PC. Whereas if you are having account in Google Colab, this can be directly opened in Google Colab. Okay, what is the first thing that has been done in the coding? You have to import the necessary libraries. So you have to import NumPy. NumPy is a library array and vector operations, as I told. So Keras datasets import MNIST dataset, as I told, it is maintained by the Keras machine learning library. So you need to import the machine learning MNIST dataset, and you are importing the sequential. What is the sequential? Is a model that is you have functional API in machine learning projects. So my system is getting little hang. Yeah, as you are seeing in the, if output of one layer is given the next input of next layer, it is a sequential model. It is maintained as such till the end. It is a sequential model. Otherwise, what is functional API? Functional API sense. Yes, in SNET. In SNET is not the case. There are some parallel layers. So that has to be accompanied by functional. So the rapid disks are enabled. That means it is offering some computational space and also some disk space. I'm not paying anything. The Google Colab for academic research purpose and all, the Google Colab free version is more than enough to do our deep learning project. And also from Kira layers, we need to import dense fully connected layer. Max pool, you have the fully connected layer. Before that, you have dropout layer, flatten layer. All the layers are being imported. And so there are some NumPy utilities, like to convert to categorical. Categorical means qualitative. So to convert some of this to qualitative, need is command. So for that, we are importing everything that is required for this particular project. And I am running that particular shell. And the seed is equal to 7. So this is for so to initialize, it has to be randomly initialized. So for that, you need to use this command. And the next command is nothing but you have mnist.load.data. So this is the simplest thing. So the coolest thing I told, mnist data is the hello world of machine learning problem in the sense automatically categorizes the mnist data set into X train, Y train, X test, and Y test. You know better what is by X train, Y train, X test, and Y test. Exchange number the image features or images which you take for training the algorithm, that is called as X train, Y train. For the training features, for the training inputs, whatever is a label that is said to be Y train. So X train is the input features, Y train is its label. Okay, let us proceed quickly. And this particular data set is being totally split up into X train, Y train. That is some of the images, the numeric images, and their corresponding labels that are being segregated, and some testing labels, testing images, and their corresponding tested labels that are also properly discriminated from this particular data set. And what is the shape of the text train I'm going to run? The shape of the X train takes 60,000 images, each of size 28 by 20. As I told, when I discussed the data set, the MNIST data set is 70,000 images, each of size 28 by 28. For training, we have 60,000 images. Let us see what is the shape of Y train. Y train is what is the labels. Okay. 60,000 images are having values. It can be from 0 to 9. 0 to 9 in the sense. What is the first image? You take the first image. Likewise, 60,000 labels are there. And similarly, Y test. After X train and Y train, we have Y test. My is the problem. Okay. So now you need to import any functionality, you need to import from the appropriate library. So here are the image, load image. If you want to visualize an image, you want to import the functionality. Likewise in Python, we don't have any other chance. We need to import all the functionalities. So before starting to code, you need to see what are all the functionalities and what are all the libraries I will be using. You should be loading all those libraries and you should be importing all those functionalities also. So far what we have done, we have imported all the libraries and we have also We have imported all the libraries, and we have also downloaded the MNIST dataset and categorized and segregated into training data and testing data. The label for training data is we train, and the label for testing data is we test. And we have just checked what is the size of all those things. And finally, we have imported libraries and functionality for plotting the images. So, for example, if I run this particular line, so what I told now 60,000 images. So one point I would like to say here is Python syntax starts from 0. So 60,000 images, 5,999, 0 to 5,999. They explain maybe wondering as is explained, one thing we have to be careful about is Python syntaxing starts from 0 to 60,000. We have imported the library and we have segregated into training data and testing data, and also training label and testing label. So images, 60,000 images, 10 images, 60,000 images labels and 10,000 images labels. And what is their sizes we check. And if we put 1,000, it is simply showing out of bounds, right? Because Python indexing starts from 0 to the last. So 5,999. We put it will show the last image. Put 1, it will show the first image we are seeing. The first image also. It's 5.8. The MNIST data set is having the numerical characters. As we have already seen explanation. This fashion MNIST. MNIST is nothing but having the numerical characters, and this is train. So if you want to divide some of the images for training, so this is my X train totally, and this is my X test for testing, and their corresponding labels. Corresponding labels are taken as X test and Y test. For the training class, X test to be taken for zeros. Correspondingly, it should be 0, 1, or 2. It should be standardized values. And after what we are doing now, we are reshaping to a shape. Extrain shape of 0. Extrain dot shape now. What is extrain dot shape? The shape of extrain is 60,000, 28 by 20. Shape of 0 means it will take 60,000. Shape of 1 means it will take 28. Likewise, the indexing goes there. So 60 for all the 60,000 images, we are flattening as 1, 28 by 20. That is being reshaped. And afterwards, we are normalizing the gray levels. So these being grayscale images, the values range from 0 to 255. This is one of the conventional steps done in any image processing project. You divide all the pixels by the maximum value of the gray level. So suppose if you divide by 2, output will be from 0 to 1. So all the values or all the pixels in that particular image will start ranging. Next, one more important line. You know what is by train and test? I told X train is the images, training images. X test is the testing images. For training images, labels are there. Labels from 0 to 9. So what is by categorical? Categorical means qualitative. So qualitative in the sense that suppose this label is 0, its value is not 0. Its label is 0. That's why we want to convert that to categorical. So that is one of the important steps in machine learning. We have qualitative data that has to be converted to categorical. That's why you imported the NumPy based utilities when you importing on the libraries. On num classes, what is the number of classes? Y test dot shape of 1. What is that y test dot shape of 1? See. What is the shape of y test first of all? The shape of y test is 10,000. So 10,000 images, each having 10 classes. So if you put to 1 of 1, it will give 10. So why you are declaring this to a particular variable means? You can have a logical thinking. Suppose I want to do a design a convolutional neural network. What I told in theory, when you design a convolution neural network, what is the number of output nodes? That is an important question. Suppose if it is a 3-class classification problem, there should be 3 nodes at the output. If it is a 10-class classification problem, like MNIST dataset, whatever we are holding out, so there you should declare 10 nodes at the output. That is what. And that is why you are just in a variable. Some class is equal to. And afterwards, we are defining a model. We are defining the model. What model we are defining? We are defining a sequence. What is a sequential API and a functional API? Meanwhile, I will run this also. So, I are taking a sequential API which consists of convolution layers that consists of 30 filters at the initial stage. Each filter is one by one. Okay, MNIST being having the input shape of 28 by 28. If you have many convolution layers, the size gets decreased every time. So that ultimately sometimes the size goes to negative also, which will not be accepted. That's why I'm not putting a 3 by 3 convolution filter. If I put a 3 by 3 convolution filter, the size keeps on reducing. That becomes a problem. If you are dealing with the image of size 512 by 512, you can go for convolution filters of size 3 by 3 also. So now just to escape the problem, I have declared a convolution filter of size 1 by 1. Whether a filter of size 1 by 1 will be useful also. And what is the activation function I'm using? So all the concepts we study, activation function is nothing but a ReLU. Afterwards, we are having a dropout. Dropout is nothing but dropping out some of the neurons. 20% of the neurons are being dropped out. That is to avoid overfitting. What is by overfitting? Overfitting is nothing but my algorithm is becoming fit for only a certain inputs, becoming unfit to new inputs. So to avoid that, we are dropping out some of the neurons, and we are putting a flattened layer also, and finally fully connected layer. If you go through the block diagram of a convolutional neural network, that is what we are convolutional implemented, maximum layers they are implemented, fully connected layer are implemented, and in every convolution layer there is an activation function also. When I by block diagram, the convolution layer activation is not shown here, I told, but anyhow, activation function has this ReLU. And one more thing, important thing I told, activation function you can use in this convolution layer in this fully connected layer. But in the last fully connected layer, softmax should be the activation function. So softmax activation function you are using, that is giving the probability. And what should be the number of nodes in the output? So in the previous fully connected layer, any number of nodes can be used. This can be 500 also. If we increase number of nodes, if we increase number of layers, then complexity keeps on increasing. Okay. But the final dense layer should have the number of classes. That means 10. So only 10 nodes will be providing the probability of the 10 class. If you make a mistake here, the output will throw an error. And after that, you are compiling the model by loss. What is by loss function? What is by optimizer? Optimizer, you know something actually already. Gradient descent is one of the optimizers. So I told that gradient of error, rho e divided by rho w, that is rate of change of error with respect to weights. So this optimizer is in fact the particular module that is driving the. If I talk all these. What is the gradient? Dou e divided by dou w. So the optimizer or gradient descent algorithm, gradient descent is one of the optimizers. So there we have used some other. So those optimizers are the things that are the weights change direction that reduces the error. So why we change the weight? Reduce the error. So optimizer is a particular thing that is weight change in a direction that reduces the error. Is what is the optimizer. And this is what is said to be the error calculation. The error calculation is here told as a loss. So loss function is something. Several types of loss functions are there. The loss function for us image you are calculating the error that will be loss. Here several images are there. Each image you take and you calculate the error function or loss function. So the loss function will be proportional to y train minus, y test minus y predict, where y predict is the algorithm's prediction and y test is the actual ground truth. So the ground truth has to be compared with the actual algorithm's prediction. Ground truth has to be compared with the algorithm's prediction. That is what is y true minus y predict, where we calculate the error. So before going to the full error, what we are going to do now, calculate it for a single image by that is the last. So then we declared a model, and after declaring the model, we have to fit the model. When we fit the model, we have to say what is the training and what is the label of the training data. Training data is nothing but in the MNIST data we have taken out of 70,000 images, 60,000 images. And Y train is nothing but their corresponding labels. We told that the MNIST automatically segregates. When you give the MNIST load of data, and on the left hand side, the corresponding entities, there is X train, Y train, X test, and Y test. MNIST.load data, X train, Y train, X test, Y test. It correspondingly takes the training data and its label, testing data and its label. So that is the input that should be given for the model when we compile. So how many epochs we have to say? 10 epochs only we have taken, because this being a simple task, we have taken only 10 iterations and batch size of 200. So for every 200 images, it calculates the error for that problem. So, and when we see, the accuracy keeps on increasing, starting from 0.87, 87% of accuracy we had in the initial stage itself. And this is only validation accuracy. So validation accuracy in the sense, so here it is given somewhat validation data, Y test is taken, but generally validation is done only with the training data. So it is like an internal exam. Okay, whereas actually with the new data, that is like a final exam. So for the final tested data, the accuracy is also shown. So the final for the tested data, the accuracy error is shown 2.18%. So almost 98% accuracy it has classified for the minimum of 20 iterations itself. That is what is the classification of MNIST dataset using Google Colab. So here segmentation project also. We have taken a simple encoder decoder based CNN. Even though I have drawn the unit, this is not unit. This is a simple encoder decoder based CNN. So what are all there in the encoder in the sense? There are several convolution layers. Each arrow in fact depicts a convolution layer, and there are 8 stages of convolution layers. So what happens after the convolution layer? You have max pooling. So that is what is shown by the light blue diagram. Batch downsampling or batch downsampling or max pooling. So what happens in the max pooling? Now the size reduces by half. So convolution reduces the size by 1 or 2 pixels, whereas max pooling reduces the size by half. So what happens after each convolution and max pool combination? Each combination of convolution and max pool, the size almost reduces by half. And this is what is my X train, and this is what is my Y train. In the supervised learning, what should be done? This pixel has to be learned with respect to this particular pixel as a background. This pixel has to be learned with respect to this pixel as an optical disc. So likewise, we have to give the X train and Y train lines. Okay, this is my X train and this is my Y train with several encoding and decoding layers. Why we need decoding when we go? The size image gets reduced now. But ultimately, what will algorithms Y predict? My algorithms Y predict also image. So what has to be done? The that has to be compared with the ground truth. So always algorithm prediction is compared with the ground truth. So in that sense, what I require, suppose if this is of size 512 by 512, after getting the sizes reduced by the convolution layers, if I have a small image that is of size 50 by 50, this is of size 512 by 512, it is not possible to compare. So for that, we are doing upsampling and decoding layers, the size of the image gets increased. Whatever is the original input size or the ground truth size, the actual algorithm segmented or predicted maps will be here, and that map will be compared with the ground truth. So that is what is the error that is being calculated on the background. So in the each of the encoding layers, what we have a convolution and padding. Convolution padding is one of the operations in convolution, and also max pooling. Max pooling is there. That is what is there in the convolution layer. That is what is in the encoding layers. It has convolution layers and downsampling. And in the decoding upsampling, we have to increase the size of the image. Of course, here also we have convolution layers which are going to extract the features. As we told, convolution layers are simply used to extract the features. So, time to run this code. Explain this code. So this is one of the typical examples, an interesting example where all the images can be operated from Google Drive. So if you look at my Google Drive, I have saved all the images in one folder. In my drive, the images I have saved all the images, and in my drive, in a folder called labels, I have stored all. So what is the supervised learning that has to be accomplished for this particular image? This GS. The database is from IIIT Hyderabad. This GS dataset I told. This GS 002. That has to be this label is 002 optical disk segmentation. Likewise, a couple labels are also there in this particular data set. Now I am just trying to explain the optical disk segmentation. So how you read the data? Line that is used to mount the Google Colab environment. You have to mount your Google Drive, and this is a line to authenticate your entry into your Gmail. So this line authenticates to your and import OS. OS is a mount that is used to create and access directories as a whole. So that particular directory called images. That images is the directory that is having. So all those 50 images can be accessed at a time. So I save in listing 1 my images and I save in listing 2 the labels. So the thing I can tell is you can also deal with 30,000, 40,000 images like this by saving your Google Drive. This being a segmentation project, we are not having 30,000, 40,000 images. This is again a story of 100 images. And you are importing NumPy that as usual you already saw in the MNIST exam itself. And what is the size of listing? Listing 1 is nothing but it is having all the images. So the size of listing will be 101. Again, you are importing all the libraries, OpenCV, that is CV2, and import glob. Glob is one of the modules that is used to fetch different types of data. And you are importing dense layer, max pool layer, convolution layer. So for the different codings, I have shown different styles of importing. From different libraries, we can import this. And you are importing model also. And you are taking a path for the training images. In my drive, images is a folder that is holding the images, and in my drive, labels is the folder that is holding the labels. And there is a function file that is developed to read the images, and that is saved image and also as a color image. So I have not shown that function. So this is typically taken from GitHub only. GitHub for some other experiment they have done, and we have ported it to segmentation of optical disk and optical couple. For segmentation of some other task is given. We have done it for optical disk and optical couple. And afterwards, training or train OD path, that is mask. So what is test path and training path? Yeah, training images path and training optical path. Images is nothing but those images. Images are nothing but this. Optical disk means this. That is what I shown here also. So the appropriate path data saying what you afterwards what I see now, I'm just showcasing the linear image. Map means the color image and the mask means the corresponding ground truth or optical disk map. So why I'm doing this particular step now, I can change. So totally 101 images are there. 95th image also I can see. So I have to see whether the particular image and particular label are not mixed up. Some rearranged. So when you are learning, when this particular optical disk is here, this has to be particularly here, specifically here. Otherwise, there is a mix-up in your folder which you have. So I am seeing, just seeing input. So sometimes in electronic laboratory, before seeing the output, we see the input. Likewise, we check with the input and confirm with the input. Afterwards, there are some of the conventional steps. We are resizing both the images and also the labels to a size 768 by 512. Because after it is going to be operated by convolution filters, every time the size is going to get reduced. That's why we are doing this step. And afterwards, what I am doing now, here my training data, I take first 90 images. So when I explained about this Drishti GS data set, I told 50 images they take for training and 51 images they take for testing. And this is not a built-in data set like MNIST or Fashion. You can take the images and put everything in a single folder. I don't want that style of training and testing. I want 90 images for training and only less images for testing. So I can do like this. 90 means first 90 training, remaining images for testing. 0th image to 90th image for training. Likewise, the corresponding labels also. Images I take as train data, X-train data, and labels I take as Y-train data. Okay. Similarly, testing images I take as X-test, testing labels I take as Y-test. This, in fact, you may be knowing by now. X-train, Y-train, X-test, and Y-test several times I told it. And we have to define the encoder and the decoder. What is the encoder? I told 3 convolution layers are there in each encoder. With activation function called relu, and padding is equal to same. Why padding is equal to same we are giving now, otherwise the convolution also makes some reduction in size. That is going to complicate my project. Why? Because being a segmentation project, the size of the output should be same. So one thing I can manage, at every encoder there is a max pool that is going to reduce size by that I can manage with the decoder. Every time you do an upsample, we manage. And finally, we call for the entire model. The entire model is having 8 encoders and 8 decoders. That is what we show this also. Afterwards, we compile the model with a measure called that is adaptive momentum. That is adaptively modifying the learning rate. And loss function, we have declared own loss function. Previous thing we told categorical cross entropy. We have defined a mixed loss function. And based on that, if I run that code, model.summary, always you can see the model. I told if you take an input, so I'm not just running this code. This is already being run because if I run this code, it is going to take more time. So already it is run yesterday, and the output as it is. So initially, I take an image of size 512 by 768 of 3 channels, red, green, and blue, and each convolution layer is adding 16 more channels. So 16 convolution filters I am taking. Afterwards, there is a max pooling. That max pooling reduces the size by half. And when the size is reduced in the next layer, I'm increasing the number of filters, 40. And likewise, this is a complete encoding. That is, the size is getting decreased. And afterwards, decoding. Decoding, the size gets increased again. And again, you have to end up with 8 decoders so that the size again becomes to 512 by 768. So encoders where the size gets reduced and decoder where the size gets increased. And it is conventional to increase the number of channels. When the size gets increase the number of channels. That can also be seen from the coding, from the model summary. You can see in the coding also. Every time you call the encoder, you increase the number of channels because every time the size gets reduced, there for compensating we are in number of channels. And then here we are decreasing the number of channels, whereas the size will get increased because every time we are having a upsampler. Here you have a max pooling, which reduces the size. So finally, when I compile the model and fit the model, what I have to fit it, X-train, Y-train. X-train being the input images and their corresponding labels. Then I have to fit the model. When I fit the model, as usual, the loss is being calculated. Then we go for predictions. Model.predict of X test now. Already the model got trained with the training keys, the X train and Y train. With the X train and Y train, afterwards we have to test the model. What is it? So not one images are there, 90 images they have taken for testing. The remaining images they have shown like command from images for testing. Those images and their corresponding. That is what is the meaning of the predictions. So when you do the model.predict of X test, the X test input images will be tested. For which I plot, this is the original one of the original images I am taking from predictions. Okay, few images of I one of the images, and it's algorithm prediction. My algorithm is predicting the segmentation of optical disc like this, whereas the ground truth is like this. This is the ground truth in the sense we know this is supervised learning. For both the training data and testing data also we have ground truth. But when we do the coding, what we do, when we give X train, we give the Y train. But when we give the X test, we don't give the Y test. Then that becomes meaningless. The algorithm has to be able for X test. The algorithm has predicted the X test. It is being compared with the ground truth. This is pixel by pixel. We have to see whether that is properly counted or not. For which we calculate the accuracy of segmentation. The accuracy of segmentation comes to around almost 98%. So that is a typical segmentation of optical disc. The classification of tabular dataset can also be researched in some other platform. So, any queries? So I am ready to conclude my presentation. If you want to ask something, you can ask. If it is possible for me to address, I will address. Moderate.
Professor Chandru, am I audible?
Yeah, madam.
Okay, sir, my question is, are there any standards or RFCs related to AI in medicines?
Standards. Standards in the sense, what do you mean, madam?
Uh, like, there are RFCs for different technical things, no? So, is there any ongoing discourse regarding this? If it is in your knowledge, if you may share.
Standards in the sense, there are no standards. We have data sets. We can train and test our algorithms with the data sets. For example, if you want to test on real-time data, you want to go for hospital ethics committee and all. But most of the research was we are restricting with the online data sets itself, which are ground truth and which we don't have any problem with the ethics committee. Otherwise, some researchers publish with the real-time data set also, that has its own value. They call it as the prospective data set. They keep on adding new images to their data set that are being taken by the doctors. In such a situation, you have to conduct a meeting with the ethics committee formed with the physicians we are going for retinal image research, ophthalmologists and also engineers, and that is not going to cause any harm to the patient, and the patient data is not revealed. Likewise, the ethical committee should approve. So that such a standard is there at the time aware. You go for some real-time projects. But as of my interest, as of my knowledge, any publication can be done without all those things. You want to seek some funded research, then you can go for some real-time data where you need to do all those things.
Sure, sir. Thank you.
Hope I might have addressed your answer.
Yes, sir. Thank you.
Thank you, madam. Thank you for your question.
Sir, can we conclude the session? Or else we can wait for some other minutes.
Yeah, thank you all for patiently listening to the lecture. This, in fact, has been a longer session only. Thank you very much. And if at all there are no questions, we will conclude the session. Yes, Sangeeta, we can conclude the session. Thank you all.
Thank you, sir, for your enlightening session. Today we had an opportunity to learn about AI in medicine. I request all the participants to fill the feedback form provided in the chat box. And also, I like you to remind to attend the quiz session in the evening. I would like to thank all the participants for your active participation throughout the day. Thank you all once again.
Miss Sangeeta,
Yes, ma'am.
this classroom is deactivated. Where we find this link for the quiz?
It will upload it in your WhatsApp, I think so, ma'am. I will get clear with Hemakumar sir and let you know, ma'am.
Okay. Because day before yesterday's session, I attended till last yoga session. However, I did not receive that quiz link. On the chat also, I asked in call chat.
Okay, ma'am. Just a second, I will ask the sir and let you know, ma'am.
Sure, ma'am. Thank you.
Ma'am, the quiz link is already uploaded in the WhatsApp group, ma'am.
Sure, thank you.
Thank you, ma'am.